Hello, my name is Daniel Sensky. This is my final project for Module 8, Assignment 2 for Microcontrollers class. My project is a sprinkler controller that has intelligent inputs for sensing ground saturation or water. In the event that there is a ground saturation condition or rain, the microcontroller sets a rain delay and indicates to the user that a rain delay has occurred. I am using an Arduino microcontroller and a variable potentiometer, variable resistor for setting the timer for the sprinkler output, and a breakout board for the relays. For starters, I had to plan out how the flow of the program was going to occur. So step by step, it starts, the variables are declared, you set up the pin modes for Arduino, and then I utilized serial communications for troubleshooting and evaluating the potentiometer input to the A to D on the microcontroller. Then it reads the value from the resistor to set the sprinkler time. The microcontroller then checks to see if there is a high condition on either the groundwater sensor or the rain sensor. If there is, it sets a 24-hour delay and indicates an LED that a rain delay has occurred. If there is no rain sensor and groundwater saturation, the sprinklers need to come on. So the relays are turned on for watering, and then the delay is set for the timer based on the variable resistor value that sets the time that the sprinkler should stay on. After that time, then another 24-hour delay occurs to cycle to the next day. So in the Arduino, starting with the beginning of the program, the header and variables are declared. Then we move into the void setup where this occurs one time. This is used for setting the pin modes for the microcontrollers, such as the outputs and the inputs, and to begin the serial communication. This is the serial communication window for the Arduino microcontroller. This is used on the potentiometer feeding into the analog input of the microcontroller that has an onboard A to D converter. This converts a voltage signal from the potentiometer into a digital reading that can be then used to set various things. I'm using it for setting the timer value for the sprinkler time. So as we can see, like right now it is detecting 38, and that sets a value of 1 minute. Actually it's 1 second because to speed things up for demonstration purposes, instead of being days or minutes, I have this set everything to seconds. So as I rotate the potentiometer, you can see that the values will increase. Oh, wrong way. That is decrease. You'll see the values increase. There. And a value of 118 on the sensor sets the timer for 3 seconds. So I have a day delay for this project. I set it to 10,000, which is 10,000 milliseconds, which equals 10 seconds. So we go into our pin mode, we start our serial communications, and then we run the loop that checks to see if the sensors are being made or open. The way Arduino inputs are utilized, they're constantly shorted to ground, and when they see an input condition, they have the VCC or 5 volts sent to the pin, which indicates a high condition on the input pin. So here's the code that checks to see the loop for if the inputs are on, and if the inputs are on, then it goes into a rain delay. And the rain delay in this situation is 1 full day to the next day. If there is no rain delay and the outputs are still low, then the sprinklers will turn on. And so the every day the sprinklers will turn on at the same time, I enabled it to subtract the day delay versus the timer value. So if the timer is set for 3 seconds for the sprinkler time, it takes 10 seconds for the whole day minus this 3 and sets the day delay to 7 seconds. So as you can see, here's the microcontroller and the variable pot. Right now I have it set for a 10-second day, and this is simulating that the sprinkler turns on for 3 seconds. Turns off, and then it waits for the next day. So instead of using actual real-world sensors, I'm simulating using just the breadboard capability. If we have, say, a condition where the rain has occurred, like this, then what will happen is that at the next check, it won't turn on the sprinklers, and should indicate there that there has been a rain delay. If the condition is cleared, such as this, then the cycle restarts on the next day. Thank you for viewing my project. And once again, this is Dan Sensky for Microcontrollers Electrical 307 Final Project.